OMG, let's talk about Newton's laws. OMG, here they are. Okay, it is easy to remember Newton's laws in reverse order, so I'm going to go from 3 to 1. So the third law states, if object A exerts a force on object B, then object B exerts an equal and opposite force back onto object A. So the forces are balanced. So let's take a look at this now. So this is object A. This gentleman is pushing on object B, which is a very heavy cart. Now he's probably not got enough force to move this, so the force that he applies, which in this case is 100 newtons, nice little figure there, is equal and opposite to the force that this applies back. So he's not going to be able to move this because it's applying an equal, the same size arrow, and opposite the arrow in the different direction, okay? So if this is east, this is west. This applies in everyday life, so if you put a cup or anything on a table, then it's not going to fall through the table because this table applies equal and opposite force back on to the object at rest. Okay, Newton's second law is F equals ma. That means force, or resultant force, equals a mass times acceleration. So if there is a resultant force on an object, it will begin to accelerate because forces are now not balanced. Oh, so you can see this little fella here now, right? If he is strong enough, he can apply 200 newtons, and this is only giving 100 newtons back. So this arrow now is longer, okay, even though it's in a different direction, but we've got a resultant force now, which is 200 newtons minus 100 newtons. So we've got a resultant force of 100, let me just write it in, 100 newtons. Lovely. We can even work out the acceleration now. So if an object starts accelerating, we can either do it the triangle method, the easy way. So you put your finger over acceleration and you're looking for your force over your mass. Well, your force was 100 and your mass would be 1,000, and you type that into your calculator. Or you can do it the rearranging way, where you've got your acceleration, so your force, 100 there, equals your mass times A. I'm going to divide both sides by 1,000. Therefore, get rid of that, and that becomes 1,000 down there. And then I'm going to cross off the zeros, and it becomes 0.1 meters per second squared. Now, Newton's first law, also called inertia, an object will remain at rest or uniform motion in a straight line unless acted on by an external resultant force. These forces are balanced. Let's have a look. Inertia is kind of a resistance to change in motion. The more mass the object has, the more resistance it will have to motion. If I was able, in space, to move this truck or this trolley, okay, and if it was in space and no other forces acting on this, it will continue forever and ever and ever in a straight line unless acted on by another force. So if another force was going to come in, okay, it would knock it this way then. Okay, lovely. We all love Newton's laws. We all love Newton's laws. We all love Newton's laws. There's 3 to remember.